The tricky part about all of these is really deciding, first off, am I using binomial? Am I using geometric? Am I using PDF? Am I using CDF? Is it 1 minus? Is it not 1 minus? Do I include the number? Don't I include the number? Oh, dear God, my head's exploding. So, when we're looking at a problem like this, I really, really, really need you guys to start. Because remember, just like any of our hypothesis tests or our confidence intervals or anything that we do, you have to start with what? Assumptions and conditions. So I want you to want me. No, I want the projector to work. Okay? No, it's not. Here it comes. Okay. Flip. Yes, I probably will try to remember to edit that one out. Hey, wait a minute. Where'd it go? I could, but I'm not going to. All right, hang on. Dumpster move.
Can you put the whole audio?
It is.
Unedited?
Yep. Okay, here it is. Lovely. All right, so what I want you guys to do with this, like I was saying, is you need to start by listing your assumptions and your conditions. So for this guy, that means...
We just keep forgetting steps, and we think we're doing it right, and then we just forget.
Oh, okay. So you start off with the idea that for this problem, you're looking for your assumptions and conditions. Either it's binary or it's not. Independence. Well, when it comes to blood types, your blood type really should be independent of the other person as long as it's been selected randomly. Because, like, I mean, if we're in a family, it's not going to be independent. But if it was a randomly selected survey, it should be. I want to see what you're identifying as your probability of success. So for this case, I'm saying the probability of success is the probability of getting that type B blood. So that was 11% or 0.11. Now, in these problems, we're going between geometric and binomial. So I'm going ahead and describing both of them as well as what their distributions are. So when it says go until, yes, ma'am?
So do we not have to write the failure one?
You do not need to use the success failure unless we're going to be approximating with a normal model. Oh, are you talking for what the failure? No. Because what we do is we just assume, okay, the failure is going to be 1 minus that. And that's why we have the binomial condition. Okay, let me do this real quick. This is not getting really pretty. There we go. Somebody let him back in, please. All right, so I define X to be the one where I'm talking about number of trials until the first success, until I get my first type B. Whereas Y is the number of successes in a set number of trials. Go until is geometric. Set number of trials is binomial. And I just put N here because that N changes through some of the problems. Yes, sir? Yes, it's the wrong problem. Thank you. I was really getting excited about the old problems. Brandon.
For your binary, does that say type B or type A?
Type B. So what the type of thing that I'm expecting you to write here is as we go through and we do these problems, the first question said, how many blood donors should the American Cross expect to collect until it gets? So is that a go until or a set number? That's go until. Okay? It says, how many should you expect to collect until it gets a donor with type B blood? So that's go until. So is that geometric or binomial?
Geometric.
That's geometric. So when we look at this, I'm saying the expected value of X because we're talking about the go until. And the formula for that is 1 over P. So it's 9.1 donors. Your labels are going to change for each of these. One of them is going to be how many people. Second one is going to be how many people with type B blood. or how many successes you have. So you got to be real careful with that. And then on problem number, come on. Problem number 2 says, what is the probability that the 10th blood donor is the first donor with type B blood? Is that geometric or binomial? That one's going to be geometric. So what do you need to show for a geometric problem? You don't need, like I wrote this down just so that you knew what, because I couldn't see the problem anymore. I have to see this and either that or the calc speak. Either one of those are okay. Remember, this is the one chapter in the entire book that the calc speak's allowed.
Do you want it to be like in the format of P equals X equals, or can you write like how it comes out in a calculator, like parentheses and just the numbers?
No, I need to see because this is telling me what you're calculating.
Right, I have that part, but like for the...
Oh, you mean here?
Yeah.
No, you have to give me the variables because, again, we call this calc speak. Yes, we're doing it on the calculator, but you can also have tables that say this exact thing, and you have to understand that we're looking at the table where the probability of success is 11 or 0.11, and we're looking for a sample size of 10. Okay? So you want to make sure that you're very careful that this notation is there because it tells me what are we solving for. This tells me how did you get your answer, and then, of course, your answer. Okay? Does that make sense what I was talking to you before, Hannah, about needing this? Okay. Okay. And then problem number 3 said, what is the probability that exactly 2 of the first 20 blood donors have type B blood? So, geometric or binomial? Binomial. PDF or CDF? PDF. It is PDF because if I write this out, I'm looking for that equals. Equals is always PDF. You have a question, Austin?
No, I just wrote it wrong. I was confused to see if like, the notation was N and P and X.
And what you can do, we'll pause this, but when we come back for lunch, it's all about what order do you put it in your calculator. That's just the order you write it down in.
For the assumption conditions.
Yes, sir.
The X equals Y equals, does that cover for both geometric and binomial? So you don't have to
Because that way I see, here's the geometric, here's the binomial, you're all good. Take it from there. So, if you guys, I don't know if I answered your questions before lunch or not, so what do you think? Did we get to what you were asking about?
Yeah.
Yeah? Okay. All right. So, can I get someone to shut the door for me, please? Thank you, Drew. Try not to bleed on it. Ba-dum-bum. Not so much. Pretty sad. Okay. All right. Now, for problem number 4, it said, what's the probability that at least 2 of the first 10 donors has type B blood? Geometric or binomial? Binomial, because we have a set number. And when we're saying at least 2, though, you want to make sure that you're very careful. And this is where people start having some issues. At least 2 means I include 2 and I go bigger, right? Pretty straightforward. Well, on your calculator, the CDF function only finds area to the left, area under, area less than. Okay? So, what do I need to do with that? 1 minus the CDF, y is less than or equal to 1. Because if I'm looking at this, 2 is not going to be included in this. I am crossing out, I am ignoring the 0 and the 1. So you've got to be very, very careful. Now on your flip books, the back of your flip books under your note cards, let's see here if I have it. Here it is. Someone's having way too much fun over there. I hope it helps if it's plugged in. I specifically have for you guys a spot for you to fill out right there. Exactly K, at most, less than, at least, more than. because sometimes, especially in the 1 minuses, you will or will not include that number. So you really have to think about what it's talking about. Someone let her in. Sorry, Drew, I didn't realize she was out. Okay, so be real careful about that, and you want to make sure that you incorporate that on your flip books. Okay.
Can you go over how to do it on the calculator?
How to do this one on the calculator? All you're going to do, because again, this is what I'm trying to calculate, probability that y is greater than or equal to 2. So I'm going to do 1 minus the probability y is less than or equal to 1. Now the less than or equal to, is that a PDF or a CDF? That's a CDF. So I'm going to go to my calculator, second vars, actually no, quit, I'm going to do 1 minus second vars. We're talking about binomial CDF. And what's really nice about this is the order that you put this in here is the same order that you write it down here. So trials is your fixed number, P is your probability of success, and X is the value that we're going up to. Okay? Yes, sir.
For the writing it out on the paper, would you not write X is, why would you write X equals 1 in the parentheses rather than X is less than or equal to 1?
Because CDF takes care of the less than or equal to. CDF means less than or equal to whatever that last number is.
So if it was like y is greater than or equal to like 4, it would be 1 minus.
I would do 1 minus binom CDF up to 3.
Oh, so it's basically just like
Subtract 1, right. Because if we're talking about greater than or equal to 2, 2 is included in that, but 2 is not included in what I'm leaving out. Okay? All right, now we're switching things up a little bit, and I never really expect you. That's the formulaic way of writing it out. Don't worry about it. Relax. It's all good. Okay? Number 5, now we're changing what we're talking about here. We're changing our distribution. So now we have 150 donors, and what is it asking me to do? Geometric or binomial? Binomial. And what do I need to calculate? The mean and the standard deviation. So please take a look at how this is written. You want to make sure you're using the proper notation, and all this is the formulas. Yes, sir? I knew it was binomial because the question said we have 150 donors. Assuming this is a typical number, what would the mean and standard deviation be of the number of those who have type B blood? What is the expected number of successes? So since they're talking about set number of trials and number of successes, that's binomial. If they said, how many should I have to question before I get a type B person, that would have been geometric, because go until is geometric. Okay? Now, we like to use this because there are all sorts of different ways to solve these problems, and depending upon my conditions, one of those is actually the normal model. So we like to see the expected values and all that jazz. But in order to use the normal model, you have to have a large enough sample size to have your successes and failures be greater than, not 10%, less than 10%, but greater than, NP and NQ have to be bigger than 10. Less than 10%, but the number itself has to be greater than 10. So if I look at this, NP, those are my successes. Is that bigger than 10?
Yeah.
Flip side of that, if I have $150, donors, would that be bigger than 10?
Yeah.
Yes. So because we have that, if we wanted to then turn around and use the normal model to approximate our probabilities, we could do that. Okay, but when we're coming about those problems, some of these guys, like the next one, I believe, you can solve it 3 or 4 different ways.
So you only had to find the mean and standard deviation for that one?
That's all it said. Yep. Find the expected number and the standard deviation. Yes, ma'am.
Do you have units insert like a label or anything?
On what?
Mean or the mean and standard deviation?
Yes. And if you look at mine, and you've got to be really careful with that because it comes down to which distribution you're using. If I'm talking about geometric, that's go until how many donors do I have to look at? I have to look at this many donors. For this one, it was asking how many of my donors should have type B blood. So you want to make sure that, again, sometimes that label works the same both ways, like it does here. It doesn't always work both ways, though. Yes?
So if you do your assumptions and conditions on the very first problem, that's fine for the rest.
Yep. Unless you switch gears and you try to use like a normal model, then we would tack in that NP and NQ is bigger than 10. Okay? Good. Now, the last problem can actually be done all sorts of different ways. This is the way that I've got it here. It's saying, should you be surprised if, what was it? What was the question exactly? What would make us surprised? And I actually think my math up here might be a little wrong. Let's see what we've got. So it says, how many type B blood donors would it take to convince you that this estimate might be too high? There's a couple of different ways you can do this. You can use the normal model. We've met that condition. You can use the binomial model and figure out when does the probability get less than 5%. We can use the standard deviation approach. All of these different methods work. But what you want to do for this is, so for example, on that, we had just calculated that the mean was what, 16.5? And the standard deviation was 3.83, right? Okay, so my mean is at 16.5. My standard deviation, I go out 3 in either direction. What do we consider surprising? More than 2. 3 is like smack your grandma crazy. Because you must be crazy if you're smacking your grandma. Okay, so 2 is good. So if I go up to this way, 2 standard deviations is going to take me to what?
Oh, percentage rules?
No, I'm talking about 2 standard deviations is going to take me to what values?
Bottom end is 8.86.
Okay, and the top end? And we're going to talk about which one works. One more time? Okay, now what we need to think about for this, because it says both of these are going to give me my 2 standard deviations away. So I am into my surprising range. But the question was asking me, how many people do I need to have for me to start thinking my 11% estimate is too high? If my 11% estimate is too high, do I expect to see more folks or less folks? Less. So we're looking out this way. So if I go 2 standard deviations out this way, it's 8.863. So I probably would have said, you could have said if you wanted less than 8.863. I understand that you're not going to have 0.863 of a donor. I gotcha. So maybe you said you set your limit at 8. So if I had 8 or fewer people, I would have been surprised. You can also go to your calculator and you can say, I don't know. I'm going to do binomial CDF here, and I'm just going to play around with it. We have 160 trials. Is that what it was? 150. Thank you. And I'm just going to guess. So 14 people would get me 0.3. That's not too surprising. So let's change that to 10. Up, we're close. There's the 0.05. See if 9 does it. So if I take that approach, 9 or fewer people would be surprising.
Why is it fewer if it says your estimate's too low?
Because if my estimate's too high, that means I expected more than I actually got. Does that make sense? If your estimate on what it's going to cost to go to the movies tonight is too high, then that means you didn't need as much money as you thought you needed. If your estimate on how many people are going on the senior field trip is too high, you have all this extra space and you're wasting money on buses you don't need. Okay, so it means it's actually less than that. that make sense? Yes.
If you had a second method on the calculator, how would you show your work for that?
You would say, for example, I would have been okay with saying the probability using that that y is less than 10 is 0.051. Probability that y is less than 9 is 0.026. So I would say 9 or fewer people. Okay, because there is no inverse binomial CDF. Like there is inverse normal. Yeah, there's no inverse with this guy. You just kind of have to play. Yes, ma'am.
So it's saying that, like, if you had, there actually was, like, 8 or less members, and then...
If I thought the probability, like 11% of donors had type B blood, and I went through all of these 150 people, but I only got 8. The likelihood of seeing that 8 is so small as less than, remember my alpha of 0.05? It's less than that value. So I would be surprised at that small of a number. I would think that 11%, since I have so many less than that, I would think that the true probability is less than what I actually was using. Okay?
So when you do it on the calculator, it's like you're trying to figure out what's less than your alpha?
Yep.
Okay.
I'm just trying to get your p-value down there below the alpha, some level where I would be surprised. Now 10 is pretty dang close. I mean, you might have been able to make that argument if you wanted to, but I would definitely go with the 9 to be on the safer side. The normal is an approximation. It's a much more kind of wibbly-wobbly room there. Yes?
So for the work for these, just show the normal model and then check with the calculator.
Uh-huh. Okay. Oh, they are crazy over there. Y'all good? All right, so what we're going to do today, we didn't quite get through all the problems I wanted to do last class. So we are just going to back that thing up. Remember we were talking about arrows? Did we get to the arrow problems in here?
Yeah, the bullseye.
The bullseye?
Yeah.
Arrows? Okay. So I don't remember how far we got with that.
That's B.
We got, oh, okay. Good. It's my puppy.
You change your screensaver every day?
No, I have a folder full of pictures and it just rotates through the pictures every 5 minutes or so. I think it's actually 1 or 2 minutes, but yeah. It's like the cheapest picture frame ever. It just rolls through it. I don't need to get one of those fancy-dancy little electronic ones. Okay, so this is what we wanted. And we were up to part B is what you're saying, correct? Current slide.
No, it's not. This is it.
This what?
This is an internet.
But in your, we did get through this, correct?
Yeah.
Yeah.
So we got all of our formulas.
I can do this for all your.
Shane, you should have watched the lesson from last
Okay. And then I believe, got through A and B. So when we're talking about A, her first bullseye comes on the third arrow. Is that geometric or binomial? That one's geometric. And will it be equal to or less than or greater than? What is it? Equal to. So this problem here, and for those of you who don't quite remember, this is the kind of work that I would expect to see. I just started writing down the problem so I wouldn't have to keep flipping back and forth. Sometimes I make good decisions, not all the time. So you would start by saying our 3 conditions: binary, independence, and a consistent probability of success. So it's binary because it was bullseye or not a bullseye. We were told they were independent. And the probability of the bullseye, that's my success, is 0.8. Yes, sir? Shots, because it's one person. Like if we go back and look at the problem, this is one person who is shooting the arrows. Okay? And in all reality, I don't think it's independent. You get psyched out and your brain goes crazy and it's not going to happen. But they're doing this so that we can use the rule. Because if it's not independent, we can't use the rule. And then we say, okay, because we know we're going to be doing problems all over the place, and if I list them all the way out front at the beginning, I don't have to worry about it as I go through. So we say, okay, I'm going to let X be my geometric, so where I count the number of shots until the first success, the first bullseye. And I'm going to say Y is the number of bullseyes in however many shots I'm making. And that number changes as we go through this, so that's why I left it as N. And at the same time, you describe those distributions. Geometric needs P equals. Binomial needs how many samples, how many trials, and the probability of success. And we talked last class that the probability the first bullseye is on the third shot, that's looking at this. I need to see this. That is not enough. You need to throw in either the geometric formula, which would have been that idea of, what is that? That means I failed twice and succeeded on the third time, or to write it out like this. I don't care which one of those you give me. Okay? And I'm not sure if we actually finished this problem, but I'd really like to kind of talk about these are just the different things that we're looking at here. So the probability you miss the bullseye at least once. How many shots am I taking? 6. So that means what is the fewest number of shots I could make? 0. And I could make as many as 6. Now these represent the number of bullseyes because remember, my success is getting a bullseye. So if you miss at least once, what is the maximum number of bullseyes you could hit? 5. And that pen is dead. Okay, 5. Am I going above it or am I going below it? If I miss at least once, then that means my total number of shots are below. Yes. So I'm looking here, binomial or geometric? Binomial, so that's Y. My number is 5, and what is my symbol? Thank you, less than or equal to. So we've already said that this is binomial. Is this going to be PDF or CDF? CDF. What? I know, because we switched our probability and we talked about the probability of missing was 0.2. So if I want to keep it consistent with the 0.8, they're just different. Like I said, there are so many different ways to do each of these problems. I'm going to try to keep it consistent with this, just that way I like being consistent. But you could have talked about this as if you're talking about missing at least once. You could have instead used the probability of missing as 0.2 and then done 1 minus probability of having 0. Okay, so they both work. It's the same thing. So when I do binomial CDF, what order, what comes first? So N is 6. What comes next? P is 0.8. And last but not least is what that number is. So calculate that. Tell me what you get. Starts with a 0 point. Haha. Yes. Anytime you have an inequality symbol, it's going to be CDF. The equal to symbol is the PDF. Okay? So what do you get with this one? It should be the same thing that we got last class. 0.73. One of those guys. All right.
I'm still confused. If you miss at least one.
Okay? Let's flip around the context. Okay? Let's talk about this way. Let's say the probability of a miss. What's the probability of a miss? 0.2. And we want the probability that you miss at least one. Okay? So again, what are the fewest number of misses I could make? 0. What's the most number of misses? 6. I'm saying the probability that I miss at least one. One's included in that. At least goes which direction? Is 0 at least 1? And that's why I like to draw the number line. 2, is 2 at least 1? Yes. So it goes that way. But on your calculator and on any table that you would use, you only can find the area to the left. But that's what I don't want. So 1 minus the probability that you miss 0 times. And it's going to give you the exact same equation.
I was thinking of it as at most.
Yeah.
So for that, the x would be 0, not 1.
Correct. Okay. All right, let's go on to a couple more. And this is all about the wording of the questions. Please do not let this down here freak you out. It's okay. This is the one place where Calc Speak is okay.
Wait, what did they do for that? It said 6 out of 6 hits.
Yeah, they did. Basically, again, they're talking about how we switched gears and we're looking at 0 misses. 0 misses means 6 hits. So there's all sorts of different ways to do that. Okay. Try these two. Because I don't think we got to these two last time, did we? No. Today's all practice all the time. The question seems so straightforward and simple, and yet. Is that kind of like the motto for statistics? The question seems so simple, and yet you all go home and cry yourselves to sleep on a daily basis. Okay. Yes, sir. Go ahead. Yeah, let me just do that. I'm sorry? An x value is never a decimal.
CDF would be like, so
I mean.
Okay, since we're talking about saying she, we're talking at success is a bullseye, so it would be the 0.8.
I think it might be quiet because the mic has.
Yeah, that's because I'm not talking. When I talk, it goes. Ah! Oh, you're going to be surprised if you listen to it, how loud it actually is. It's just that if it goes all the way up to the top, it's like, dude, you just broke my eardrums. All right, you think you got it? No, not yet. C is one of those problems where I actually think it's easier to write C out in the formulaic way rather than using like the calc speak. One of the few times I think that's easier. So on C, she's like, wait, no. But I like this. This is fun. Austin, what did you get?
I got 0.5.
Okay, yeah. I heard 0.096, and I was like, what is that? No. All right, so for C, am I talking geometric or binomial? Geometric, because it's a go until, right? Now, when we see, guys, when we see the word or means to add, good. So, the way I write this out, it's the probability that x is 4 plus the probability that x is 5. Now, you could have used geometric PDF with 4 and geometric PDF with 5. That just took up less space, so I wrote it like that. Doesn't matter. And when they're talking about exactly a certain number of successes, that means out of the whole lot of them, that lot that is set at 6, what is the probability of 4? That is binomial. Exactly is PDF. And we're keeping straight PDF versus CDF. Binomial versus geometric. Less than, greater than, equal to. What? Okay. Questions? Yes, ma'am.
I guess so much a question because I understand now, but
It's okay.
I did it kind of the letter C, I did it in like a reverse way. I forgot that we could use PDF for some reason, so I did CDF. I did the probability that x is greater than or equal to 4 minus the probability that x is greater than or equal to 6.
Wow, good. It should have worked out correctly, though.
So I did like 1 minus 1 and then...
And you could have done the probability that x is less than or equal to 5 minus the probability that x is less than or equal to 3. And that's the thing with this. That's fine. It's just longer. We go back to my little motto of work harder, not smarter. Wait, that's not right. Work smarter, not harder. Blah, 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 blah. Did I just say it again? Work smarter, not... Okay, good. Apparently, I'm not working very smart today. I can't even say that. Alrighty. So here are those words that you don't like very much. I'm sorry, go back. Is that what you're saying?
I just said, were we supposed to be both of them?
Of those last two problems? Yeah.
Oh, I just thought that.
Okay, well, here's a direct instruction. Do both of these. Yay. It's okay. It's Friday. No. Can I get feedback from my professor? That's a no. You get a no. If you're having trouble understanding what at least and at most is, I know it's so silly, but draw a number line. Just draw a quick, sketch it out. I know. That's why we're practicing it. PDF is whenever you see an equal to sign. CDF is when you have a less than or equal to sign.
Wait, question.
Yes, ma'am?
How would you know if it was geometric or binomial?
Because no matter what, she's shooting 6 arrows. And we want to know the probability of 4 successes. So is that a go until?
No.
I'm not saying go until you have 4 successes. I'm saying out of those 6, that is a yes. Because there's a set number of trials.
Battery's low. Hi.
Yeah.
My battery's low. I like this little thing we got going on. Cool. Oh, it's cool. It's one license, and you can speak no, successes.
Why would it be success?
You're gonna have to make one minus none. Yes, I got it. I can see it's like an actually go through it. I don't know, like I break this. See if I did it right. Wait, are we doing like this on?
Yes.
Did you use the 0.8 because you're saying like at least?
It depends upon what you're defining as your success. If you're saying she gets at least 4 bullseyes, if a bullseye is my success, then you're using the 0.8. Okay?
At most? So that would be less than.
And seriously, guys, it's a silly, simple little thing, but draw out a number line with at most, at least, less, greater, more, all of those words. It's easy to kind of think about if you're looking at it. For some reason, that makes all the difference sometimes. Huh? Okay?
No, not yet.
Now? What about now? Are you there yet? Hey.
You bought yours, Austin?
No, it's him. It's a lot of love. We'd all have to bring in
Or not buy them at all and just pay attention and get it for free.
Or copy them in Flex for free.
That's what I did at the longest time.
If you're like following along, it really should just come straight from your notes. So, oh gosh, thinking, you know. Slackers. All right, are these binomial or geometric? Binomial. Am I going to be using CDF or PDF? Why CDF? Because there's a beautiful way of putting it. There is a range of values that we can use. So,
wait, CDF?
Because it's an inequality.
So the way I did this, I think it's a lot easier for me. Again, I looked at it. It says at least 4. Is 4 at least 4? Yep. I'm going that way. So that means I'm looking for the probability that y is greater than or equal to 4. I can't do greater than or equal to 4 using a table or the standard calculator, so I have to write 1 minus y is less than or equal to 3. Because those are the ones that would be crossed out. Okay? So we would do 1 minus binomial CDF, and a 6, p is 8, or 0.8, x is 3. Whereas at most 4 counts in that still, but we're looking at this side of things. Okay? Just going to do as much practice today as we can get through. Yes, sir?
I put it in binomial CDF and 6.8 and 3, and I did 1 minus that, and I got 0.9.
That's the answer.
It's for E.
Oh, okay, I was looking at that.
I don't understand. Okay. Now, we're talking about expected values and standard deviations.
Consider our archer exercise.
I left the problem still up there.
Oh, wait. Binomial system. So you gotta do that.
Oh God, there's formulas involved here, people. Formulas? Those are what? You're a nerd. You're in this class. You are a nerd. I teach this class. I'm queen of the nerds. I am the burger queen.
No, I think 1 over p is how many shots you expect until she gets it.
You got to figure out still, is this geometric or binomial? It does matter. 2 different formulas.
Still binomial, right?
NP, that's what I think it is.
That's what I think it is too. Go for it.
Because one of them is NP, one of them is 1 over P.
1 over p should tell you.
It is definitely not.
I don't know.
No, NP is for.
I think it's funny how they do 18, A, B, C, D, E, F, G, and then 20 more arrows. A, B, C, D.
Well, it's because they keep with the concept every other problem, because they put half of the answers in the back of the book, and that way they kind of keep with the same problem.
Okay.
Oh, I just throwing it back.
What?
Yeah. No, he did like the old one.
Just.
Oh, Justin. Silly guy. Try to get back.
Okay, you're doing A, B, and C here, so please don't just do one, do them all. Lord.
Wait, if she keeps shooting arrows. Oh, see now that one is until, so that one will be geometry. Right here. I might actually pass this quiz. We'll see.
Oh, God.
Like for this bomb,
All of the work.
Like say we do 20
That's like a.
I will show. I am showing you the work that you need to show me.
I'm just wondering, like, if I have to write it down.
I am going to be showing you what you need.
She said 3 times. So what I would do.
You guys think you got it? You definitely do have it? I like that confidence. Let's see if it's well placed confidence.
1 month before the AP exam. Oh, money.
Watch your labels. Because for A and B, it's asking you how many bullseyes should you expect. Whereas C, it's asking you how many shots should you have to take until you get a first bullseye. Context, context, context. Arrows! More arrows! All right. Okay? So now instead of doing 6, we're changing the distribution. Now we're talking about 10 arrows.
22 was close out.
Still more arrows.
She made it. Oh. No, because she's shooting 10 arrows now. So that's just a set number of trials.
Good. Did you get A done? Geometric or binomial? Binomial. We have a set number of trials. Please, 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 we have changed something here, so you need to indicate that your distribution has changed.
Oh.
Now we're centered with N trials. 10. So again, your labels on these guys should have been bullseyes. So it should have been 8 bullseyes for your expected value, 1.26 for your standard deviation. Yes, ma'am.
Is it not enough to just show n equals 10? Do I have to put binomial parentheses?
Yes, sir.
So for that, would you just show that in, like as your condition or something?
Yeah, I would, and literally, I would just, before I get started, I would have said binom n equals 10, p equals 0.8. Because like whenever you're changing something about your model, you need to indicate where it is, what it's changing.
Do you have to say that to the arrows, or could you just put
Nope, that was just for me because, again, I knew problems were changing. Okay, alrighty. So, these are getting a little tricky because, again, it's all that context. It sounds so simple to find a probability she never misses.
Instead of doing like binomial and matrices, so like
You can do whatever works.
just do like 0.2 instead.
Okay.
Yeah, I don't remember.
That would work. I don't want to get in a habit because I'm not use binomial a lot.
Well, that's because that is not a binomial. It could be looked at as binomial or it could be looked at as geometric. And there's a lot of different ways that you can look at that. then you can think about that as a standard probability. That means hit, 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 hit. So it works there. You can change it to geometric as saying her first miss is not within the first 10. Or if you're talking about binomial, you can just say the probability that hits equals 10. So there's all sorts of different ways you can attack that. You'll see how I do it. Just do whatever seems right to you.
Why would you do 0? She never misses. She never misses, so she gets 0.
Losing 8, reading less. Yeah, you can see that. So never miss it. All the way. Go left. So you have to do 1 minus. No, that's I didn't know minus. Oh, that's what I did.
There are a lot of different ways that you can do that. Just saying that doesn't make it true.
I did 1 minus.
Oh, why don't you just do...
That's at least. It's like if she makes it. No, that's the makes at least 1. Don't worry so hard. I hate that.
We hate this class.
Not this class.
This unit.
I'm really gonna hate the test.
I'm really gonna hate this AP.
I'm just gonna hate next week. Next week's gonna stink.
I feel like I might be okay on this.
I hope so.
You get the test.
Sharp 46 on that.
Yeah.
It's got to be better than the last quiz.
Possible.
No, it'll be better. If I write my name on it, it'll be better.
And considering the last quiz was basically your review worksheet. I mean, it was the review worksheet, and yet it was one of the worst quizzes of the year. I'm like, I don't know what else I can do for you.
I understand this really well, and I didn't do the back half of it at the time, and then I failed the complete back half of it. So that's my problem.
Ah, you people are killing me. I used the wrong econ term.
That's
I dare.
what you make
Get that
without
W
your.
on your.
Oh, I did 6 entries. So I was wrong. Once I typed in my calculator wrong,
That would hurt also.
I forgot to multiply it by something, and then when I realized what I got, I just hit enter, hit the answer. So then I multiplied it by already wrong answer by something else. So it was an off.
It's just gonna get worse and worse, you know. All right, so let's go over this. Now, there are several different, ladies and gentlemen, please. There are several different ways that you could have calculated these next two, but your answers should have been somewhat the same, or exactly the same. So B should have given me for the first one 0.107 and for the second one 0.624. Again, there are a lot of different ways to get that, so whether you chose my method or not, that's okay. I did it this way for B. I said never miss. That means hit, 10 hits. So that's 0.8 to the 10th power. Or you could have done the binomial PDF with 10 successes. There's all sorts of different ways that you could have done that. Or you could have done a miss probability is 0.2, and that means you have 0 misses. So lots of different ways to do that. No more than 8. 8 is included in that, but we are talking about the stuff to the left-hand side.
So you
You can keep 8. Noelle, what's that look for?
I always thought it was like 8 or more.
That is if I had said at least 8.
I know what it said. Like I thought, like unless I thought if it said 8, no more than, then you have to do 1 minus.
No, and that's why I say try not to like focus on the no more thans, the no less thans. What does it mean? When you draw a number line, is 8 no more than 8? If you are only allowed to come to this party if you are 20 years old and younger, is 20 okay? Yeah, so no older than 20. So 20 is okay. So 8 is okay because 8 is not more than 8. It's equal to. Is 7 more than 8? Is it no more than 8? 7 is no more than 8. Is not more than 8. 6 is not more than 8. 5 is not more than 8. So that means I'm looking at this side. 10 is more than 8, but there's a no in front of that. I know, but I'm not trying. Okay, let's keep going still with these problems. More arrows.
Oh my god.
I think their arms getting a little bit sore.
Oh, just wait. Just wait.
Well, there's like another.
Okay, come on. This is just, guys. Woosa. I'm glad I got that on record. For all the people watching this, that was Brandon Larson.
All my Instagram.
Kathleen's just cracking up right now.
What? And you guys might not show up with the green, but you can hear it in the background, trust me.
No, bro. Exactly. Binomial. Yeah. So clearly I don't know what's going on.
Difference between end of PDF is if you have one specific number you're looking for, and then
CDF is a range.
Is it the range of numbers above?
Below. Below.
Okay, that makes more sense.
Okay?
Yeah. Sure. Yeah.
Yes.
But we still need to have our one.
Yeah. I'm sorry. What? I just.
Let's get the rock and read it all.
Oh yeah, I got this now.
What is it? I hold the lifetime.
No.
Yeah.
Guys, folks, please let's focus.
So that's the need.
Hush.
More.
Yep.
Yes, that's what I got.
Yeah.
No, it's at least.
Oh, these
Yeah. So it'll be 1 minus 5.
1 minus 5.
Yeah.
So PCF, CDF 5. It's like really big.
You look exhausted. He's like, my brain hurts. Oh my gosh. Alright, you guys get these two problems? Well, your numbers should not be bigger than 1.
Oh my gosh, you know what I mean.
Oh my goodness. Alrighty, here you go.
200 arrows? Don't.
Aaron's like, can't we just stop with the arrows already? How do we do with those two? Are you okay? You're weak.
This person isn't weak.
They're an Olympian. They're powerful. All right, seriously, are we okay with those two? All right, beautiful. Let's keep going.
Oh, I don't know what did we get to the arrows? There's so many.
I was like, yeah, getting to the arrows wasn't really clear enough. Last set of arrows problems, okay? Then we switch gears. Yay! Huh? Do a different problem. We'll talk about nibbles. Nibbles.
Like, did she say nibbles?
I said nibbles. N-I-B-B-L-E-S. I don't even know what. Oh, God. Come on. Lord, you children. Do the problems now. Okay, let's actually focus here. Oh my goodness. You're on record.
That's the fun part.
Yes, if you'd like, that's fine. Hannah.
Thank you, Hannah. Always so helpful.
Kathleen, I hope you're enjoying this lesson. Okay, guys, come on. Shh.
Can you either put like 200 times 0.8 or NP equals what they answer?
Let's do 200 times 0.8.
That too. Grandpa was like, we do all of them?
No.
She's lying. She's being sarcastic. Wait, you're being sarcastic.
He was asking about all of the assumptions and conditions. He wasn't asking about all of the problems.
I heard you something.
We're still assuming independence. Still falling under all of those things that we started off with.
We just get rid of this first.
Draw a picture. Whenever they tell you to do that, draw a picture. I want you to think on part C. What should my title be? Now, I would have considered we have been going with the same assumptions and conditions all along. Just the only thing that we're changing here is that we're talking about now out of 200 shots instead of out of 10 or out of 6. I would not have rewritten all of these assumptions and conditions. But what would the mean be for this? 160 bullseyes. What is the standard deviation for this? 5.65, 5.67. They don't normally get too angry with you when you round or truncate. So that's what we're looking at for the next one. For part B, when it's asking me, is the normal model appropriate, that's saying are my assumptions and conditions met? The only assumption and condition we haven't talked about with that so far has been success failure that's added to the normal model. So I have 160 successes, 40 failures, both being greater than 10, means it's appropriate because that is large enough. Remember doing that stuff back in the day? For part C, kind of like their picture better than mine, that's okay. Really, when they're asking you to describe using the empirical rule, you can sit down and write out, hey, guess what? 68% is going to be between 154.34, 165.66. You could write all that out, but it takes a lot less time to just draw the stupid picture. Yes, ma'am. Right. It's not, you have to do both of them. One or the other is good enough. Okay? Now, for part D, there are actually several different ways to answer that question. So I was asking, would you be surprised if she made only 140 bullseyes? Yes. And there's so many different ways. You could look at it standard deviations wise. It's definitely more than 2 standard deviations away from the mean. So that's surprising. We just went through the normal approximation, or you can use the binomial distribution. If you use the binomial distribution, probability of getting less than or equal to 140 is going to be about 0.0005. If you use the normal model, you get 0.0002. Or if you use standard deviations, it's negative 3.5 standard deviations. All of those point to one answer. It's surprising.
So we can literally, like, if we have the graph all drawn out.
You could just point up and say more than 2 standard deviations away. Surprising. Okay? All right, so now what I want you guys to do is I want you to go back to your notes, to your warm-up. No more arrows! Oh, heaven forbid. All right, so I want you to do practice quiz 16B. All. And just so you know, ladies and gentlemen, we're not going to be getting to 16D. That's the one with fish nibbles. That is in your notes packets, and the answers will be posted online. Actually, they are already there. Okay, so if you'd like more practice, there you go. Jeez, you people. I don't know which one of us is worse. Me or you guys? Okay, guys, come on. I need you working on these problems, please. Austin. Shut up. Loud, Miss Cloudy. Connor. Good job. Good job. Noah. Brandon. Come on, ladies and gentlemen, let's try to see if we can knock these out. Does your brain hurt yet? I melted your brains, all of you.
The last 3 days, I go to bed, and now here, go back.
Can I go back to sleep? Okay, we're gonna run out of time in a second. I just want to make sure you guys understand what's going on next class. What's going on next class? Quiz. Okay, so next class we're going to do our quiz. We're going to work on a little bit of practice for the entire unit. Okay, you're going to be receiving a mock AP next class. A mock AP to take home. Homework. Well, there's going to be one you're going to do over spring break, but this one is different. So this is just homework. Okay, guys, guess what? That's it. That was our last lesson. It's over. Yes. The next flip book is going to be due next week, Thursday, on the test day. Okay. And then after you guys turn in your flip books, I'm going to give you guys a cover and a back page so you can just put them all together.
Alexa, play Chpt. Alexa, play Saturday.
The second day we come back. Possibly. I need to check because I think it'd be. I'm trying to decide if I'm going to do. We'll see.